The National Electrical Code, or NEC, does not explicitly define the terms earth and direct contact with earth. However, the NEC provides guidance on grounding electrodes in Article 250, specifically addressing the grounding electrode system. A grounding electrode system is a system of conductors, electrodes, and connections that provides a path for current to flow to the earth, as described in NEC 250.52. A ground electrode itself is a conductor, such as a driven rod, pipe, or plate, that is in direct contact with the earth, also defined in NEC 250.52. The requirement for grounding electrodes to be in direct contact with the earth generally means that the electrode should be embedded in or otherwise connected to the ground, without any intervening materials that would significantly increase its resistance to earth. When assessing an installation, it's important to know that the NEC does not specify particular soil types that can be used as earth. However, materials like peat gravel are not typically considered an effective grounding medium because of their high resistivity. Wide-ranging resistance values, such as those from 16 ohms to 1100 ohms, suggest that the grounding system may not be adequately effective. To further assess the installation, consider these steps. Firstly, conduct a soil resistivity test to determine the conductivity of the pea gravel. Secondly, inspect the grounding electrodes to ensure they are properly connected to the grounding electrode system and are not damaged or corroded. Thirdly, consider testing the grounding system under load conditions to determine its ability to dissipate fault currents effectively. Given the concerns raised and the lack of definitive information in the NEC regarding specific materials like pea gravel, it is recommended to consult with a qualified electrical professional for further evaluation of the grounding system's compliance and effectiveness.